When we say that the kinetic theory of gases tells us the kinetic energy, well, that's true. And what we just calculated was the velocity, indicating it's a translational kinetic energy. But that is true pretty much for a monatomic gas. That's the whole story. So for a monatomic gas, the kinetic energy is the only type of energy the molecules can have. They're little balls whizzing around. So a monatomic gas includes pretty much our noble gases. These are helium, krypton, etc. on the very right edge of the periodic table. And we've switched to using the U for the internal energy or potential energy of the system. So the kinetic energy of a given atom can be so much more than just the translational energy. It's just one part. We can have a kinetic energy of rotation as well as vibration. So in the vibration mode, we have bending and stretching. In the rotational mode, we can spin on this axis or this axis or this axis. This one for this particular linear molecule is not going to give us much energy since they're not moving, but for an energy for a atom like water that's bent would give us another mode for energy, and then translational motion. So all of these are involved in the amount of energy that's in a system. And what we use to calculate velocity is just the translational part of that system. So for our monatomic gases, the average kinetic energy per molecule is 3/2 kT, whereas a diatomic molecule that has more places to store energy, more different types of ways it can move, it's 5/2 kT. And then for a polyatomic, so we have 3 atoms here, we get 3 kT as our amount of energy that we can store. So here we have a mixture of nitrogen and water is at 293 Kelvin, and we assume that each behaves as an ideal gas, determine the total kinetic energy for each gas. So our kinetic energy for our nitrogen is going to be 5/2 kb times our temperature, so that's 5/2 times our Boltzmann constant, which I wrote up at the top there, because I do not expect you to remember that number. I do not remember that number. So 293 Kelvin gives us 1.01 times 10 to the -20th joules. And then the kinetic energy of H2O, which is polyatomic, is 3 kBt. So we're going to do the same exact thing with the 3 in front. And go figure, we're going to get a bigger number, meaning that water can store more energy in more places than the nitrogen, which in the next chapter we're going to call heat capacity. There's all those numbers again.